The first pattern here is the most obvious, and you've probably seen this in a number of places already. It's really just planning. And the innovation here is that the AI agent doesn't need you to give it specific instructions like step one, step two, step three. It actually just comes up with the steps. Now, the caveat is it's not going to come up with the same list of steps every time. And this is because of hallucination, of course, but it usually can get it pretty close. And with enough iteration, we also introduce the idea of self correction. But this is essentially a building block for all the other patterns. Whenever you see the AI agent pop up, think of it as it can plan some actions out and then do something with those different actions. Most state of the art models just do this under the hood. Maybe it's in their prompting, but a lot of them already do this where they create a series of steps and then step by step execute. The next pattern is the research engine. And this is my favorite pattern personally because it's so powerful in what it does. This is a massive time saver. If you think of what you have to do when learning about a new topic or learning something, you have to do a lot of research. And with research comes a lot of time and a lot of effort. But what the AI agent can do is do that research as like a background task. So it can go out to the web, scrape pages, go out to different APIs, retrieve that information, interact with specific databases, whether they're proprietary or not. And it takes all that information, synthesizes it down, and gives you back a structured output. The structured output is the key here. You'd have to spend all the time putting together all that information. I think a example from really back in the days when people used to go to libraries, right? Before there was public internet. You had to go to the library, find the specific book you needed, maybe look it up in the library catalog. Now, the innovation is that we can just ask these research engines what we want. The best example of this today is Perplexity. And of course, the LLM really sits at the middle of it. I don't know how it entirely works under the hood, but this is a pattern that could be implemented in the style of Perplexity. Something like ChatGPT 4 does this. It has access to code sandboxes. There's another one that's more programmer specific, which is Find. And I think they do a really good job of giving out that structured output that makes sense for the different scenarios. The next pattern here that I have been seeing is the data management and analysis pattern. Again, this is another one that's been made popular by ChatGPT, but let me back up and explain the pattern first. Users are asking something about their data. So we put the AI agent in the middle of them and their data. Before, this might have been a full-blown data team, a data analyst, engineer, scientist, whoever. But the AI agent's job now becomes combing through the data and surfacing insights to the end user who asked a question. Now, it sounds a lot easier than it is because data can be messy. So if you have a lot of messy data, this kind of falls apart, really. And if you don't have the right data, this also falls apart. So that's where the disconnect comes in with this type of system. It really falls prey to all of the disadvantages that current data management and analytical systems have today. One technique that remedies this is retrieval augmented generation, which is often used in between the user, the agent, and then the database to help organize the information so it's easier to retrieve by agents or LLMs. The best implementation I've seen so far really is based on the basic primitive building blocks to build these systems. So I don't really know the more commercial options, but for developers and people who are working with this at the low level, Llama Index is a really good framework. They have a lot of integrations and they come at it from this perspective. It's purposely built for this use case. Then there's also Amazon Bedrock, which also has the concept of agents. And it also has a tight integration with S3 and different vector databases. So you can really build some powerful systems without having to worry about the integration piece, which I think is what's going to actually be really tough for this type of pattern, is getting the integrations right. Of course, you still have the challenge of having good data and making sure that data is organized. But if you can cross that integration hurdle first, you have a massive win under your belt already. The next pattern is feedback and act. In this one, there's some type of command that's given to the AI agent, where in previous patterns, we had a question. This one's a little bit different. We have a command. So we want an exact thing for the AI agent to do. We're actually giving it the task. It may plan some things that it wants to do later, but we want it to do this specific task. And it's going to come back with some clarifying questions. One of the classic examples I see that's implemented all over the place with this pattern is build me a snake game or a full stack application. Some clarifying questions the agent might come back with is, what type of application do you want? How many users should it support? Where should I host it? So these are going to be some of the questions the agent may ask you. And then it'll go out to some downstream system and perform those actions. In the case of something like a snake game, the downstream system really is just the user's laptop, and it might write a Python file and then allow you to execute against that Python file in the environment to play the game. Or it might be even more complex where it's acting upon your cloud account. I've seen some interesting patterns where people ask a agent to write me a Lambda in Python, and it goes ahead and does that and launches the Lambda into the account. The most adopted library for these use cases I've seen is LangChain, because it does have a couple of the right primitives to do these type of actions. I think overall, this pattern can be brittle because one, the command might be unclear, the feedback questions might be tough for the AI agent to nail and still not get clarity on what it needs to do. And then the actual agent acting upon the system shouldn't be discounted here because it's actually really difficult to map specific actions from the AI agent to the system. It might need some special APIs, it might need some special access, it might need some special tooling involved. So you do have to take a lot of care with this type of pattern, but once you implement it, it can be really powerful, especially if you know what you're doing at the low levels. The next pattern is the top-down workflow. So this pattern actually just occurs naturally within businesses where there's maybe what I'll call here the AI CEO. The AI CEO gives some type of direction. It goes out to some managers, and then it goes out to individual contributors in this sense. The power of a top-down system, it's usually easy to explain what's going on, and it's also easy to maybe detect where the issues happen. If you start with the AI CEO, you give it some type of prompt, and then it goes down to the different directors, you might be able to track where the message got lost with one of these agents, or where maybe a failure happened that one of them didn't receive the message. The benefit to this system is that explainability, but it can also be very rigid in how it works. So you can only maybe stretch it so far. And also the messaging might get once it gets down to the individual contributors, the messaging might change, or maybe some hallucinations have happened. So the end goal isn't always correct. Again, with some self-reflection, maybe some iteration, they might end up at the goal that you need. And good abstractions in the space. I'm not saying the most adopted or the best implementation so far, but this is really just based on me looking at the documentation, maybe playing around with a few examples here and there. I think the language around CrewAI and LangChain, again, really makes sense for this type of workflow. It's just easy to define. So if you're going to pick up a framework in this space, those two frameworks work. But I've also seen people who they can implement this from scratch on their own. It's going to depend on how much time you have and how much control you want at the low level. The collaboration workflow. This is where you have multiple agents that can communicate freely with each other. There's no structure that's imposed on them, but they can also work on different tasks and hit up a different agent that maybe is a specialist in a specific task. So I think a good example for this would be like maybe a content creation team of agents. You make one like a creative director, you make one another strategist, one is supposed to generate thumbnail images, and one writes YouTube scripts, and then you just let them loose, give them a couple of resources. So once those ideas can come back and maybe get approved by one of the other agents. Another good example of this was a paper that was released a while ago called Chat Dev. In that scenario, essentially what they had was a developer team. So where in the feedback and act pattern, a user is telling, hey, build me a full AI app, and then they'll wait for the agent to do the work. In this scenario, we give the agents the same goal, but they're allowed to collaborate. And so there's some specialist agents here that are responsible for specific components of building the application. Now, there could be one for testing, there could be one for UI design, there could be one for backend development, maybe DevOps, deployment. As long as you can spin up the agents, it should work. The downside of this type of workflow is that this system can get really chatty. And especially if you are footing the bill on the chattiness, it can skyrocket your cost. And if you're unable to really explain where things went off the rails or when they're like misaligned with the goal, they can veer off pretty far away from the goal without some control over what they're actually working on. And in this type of system, I think it's best for like really long running, maybe ambiguous things that need that level of the agent actually planning it out. You don't want to give a lot of sub steps, you don't want to really give them a lot of clearly defined goals, but you want them to figure out what to do. So you should be okay with the outputs being very variable from this type of pattern as well. Again, another good abstraction, I won't say like a good implementation because I haven't really done this yet on any real serious examples, but I think the primitives are good, is Crew AI. They have they have explicitly a way you can set this in terms of creating a crew and giving it this collaboration type feature instead of a top-down hierarchy. So I like to think of AI agents as like an executable, a server, or some type of compute where I'm giving it some input and I'm getting out an output. In the traditional software engineering approach, you give some type of input, there's a specifically defined flow. But with the AI agents, instead of that specifically defined flow, it can come up with that flow on the fly. And that's where the power is, where you don't have to spend energy coming up with the predefined flows, which you may get wrong anyways, and just let the AI agents take care of that for you. All right, so that has been patterns you should know before you build and deploy AI agents. Of course, I cannot cover all the patterns here, and there's also a ton of research out there. So if there's any patterns I missed, pop them down below in the comments.